All right, so in this video, I want to factor these equations over here. So let's take a look at the first one. This looks like a perfect square to me. The first term is square rootable. The last term is square rootable. So let's try perfect square. The square root of 9a squared b squared is just 3ab. I take the sign from the middle term. And the square root of 16c squared d squared is just 4cd, and then I put a square. Now I want to do my test to make sure it's correct. So I'm going to do 3ab times 4cd times 2. 3ab times 4cd or negative 4cd is negative 12abcd times 2 is negative 24abcd, which is the middle term here. So that means my solution is correct. If I look at this second question over here, you can tell that this is a difference of squares because the first term is square rootable and so is the second term. But this is a bit difficult to do. So what I like to do is I like to use substitution to simplify this. I'm going to say let a equal to whatever's in the bracket here, so x plus 5. So now I can rewrite this equation as 225 minus, and instead of x plus 5, I'll write a squared. So I just replace this bracket with an a. Now this is a bit easier to factor with difference of squares. This is just 15 plus a times 15 minus a. Now I can't leave this as my final solution because my initial question had an x, so I can't have a's in my final answer. So once I do difference of squares, I'm going to replace my a's back with an x plus 5. So this becomes 15 plus x plus 5, and this becomes 15 minus x plus 5. But because I have a minus sign here, I need to do this in a bracket as well. Because anytime you have anything other than a positive sign, you need to create a double bracket. If you want to make this a bit simpler, I could double bracket this as well, but there's no difference over here. Next, you want to get rid of internal brackets. So positive distribute will not change this bracket at all. That's why I didn't put a bracket initially there. But a negative will distribute into the bracket and will change this to negative x minus 5 because I multiplied the negative by both terms. Finally, you want to combine like terms in either bracket. So over here, 15 plus 5 is just 20. So you have x plus 20 or 20 plus x. There's no difference between those. And over here, 15 minus 5 is 10. So this is 10 minus x. And then this is my final solution. Let's try this third question over here. Again, in this third question, you can tell that these two brackets are square rootable, so we can do difference of squares. They're both squared. But again, you don't want to do it instantly. We want to do substitution. We have two different brackets, so we're going to do two substitutions here. I'm going to say let a equal 3c plus 2 and let b equal 3c minus 2. Next, I'm going to replace this with an a. So it's going to become a square, and I'm going to replace this with a b. So minus b squared. This is pretty easy to do difference of squares. This is just a plus b times a minus b. And now I want to replace the a's and the b's back with these two equations here so I can have my final answer in terms of c's. So I'll replace the a with 3c plus 2 and the b with 3c minus 2. And over here, I'll replace the a with, again, 3c plus 2. But now we have a negative sign here, which means we got to put a bracket and we got to put 3c minus 2 inside a bracket because of this negative sign. So now I want to combine like terms in this bracket. 3c plus 3c is 6c. 2 minus 2 is just 0, so I don't need to write that. And in this bracket, I'm going to distribute the negative into this bracket. So I have 3c plus 2 then minus 3c, and then a negative times negative 2 becomes plus 2. Want to combine like terms inside this bracket, so I have 6c. 3c minus 3c just cancels and disappears. 2 plus 2 is 4, and then 6c times 4 is just 24c, which is my final fully factored solution. Let's look at this last question here. This looks like a perfect square because I can square root those two terms. So square root of 4x squared is 2x. Square root of 9 is 3. And then I want to do my test. So 2x times 3 is 6x. 6x times 2 is 12x. So this is actually not correct. You can't perfect square this. If perfect square doesn't work, I want to try my man method. So what multiplies to 36 and adds to 26? 1 and 36 don't work. 2 and 28 don't add to 20. 3 and 12 doesn't work. And then 4 and 9 doesn't work either. 6 and 6 doesn't work. So this is actually not possible, which means that this equation is not factorable.